Next section is 2.5. It's called Using Linear Models. And we're going to look at something that you would have done in Algebra 1, but I'm going to show you kind of the technology spin on it in Algebra 2 that hopefully makes your life a little bit easier. So when we talk about looking at data, you're going to hopefully be familiar with the term scatter plot. So when we talk scatter plot, a scatter plot is any graph that relates two sets of data by plotting them as ordered pairs. We do not connect the dots with this. So an example of a scatter plot, something you would have seen probably in like an algebra class, is when you take your data and every data point is represented by a point on the graph, and it truly looks like a scattering of points. That's where it gets the name scatter plot. So you might have a graph that has each person's age in the class and then their height. And so every dot on that scatter plot would represent one person in the class. So it would take the person that's 16 years old and then put them at a height of 5.55, something like that. So each point, we don't connect the dots, but we try to see if there's a relationship between the data once we graph it on a plot. Now, when we do that, we have different types of what's called correlation or relationship. So with your correlation, I'm going to kind of define each type of correlation and then give you an example of it. A positive correlation means that it has a correlation in the positive direction. So that might not make much sense, but hopefully a picture does. So a positive correlation is something that when I look at the points, it looks like the trend, the line that would be, think of the line of best fit, something you would have talked about in Algebra 1, looks like it's a positive line, meaning it has a positive slope. Now, you can have a strong correlation in positive direction. You can have a weak. So the one that I just drew, I would say, is probably a very positive correlation that's strong. You can also have ones that it looks like it lays in a line, but maybe it's kind of a little more spread out. So that could be something that we say, well, it's still a positive correlation because it still looks like these points are kind of going up. However, a lot of them are very spread out from the line. So we could say it's a weak positive correlation. So you can have a strong positive, meaning the points are really close to lying in a very straight line. And then you can have a weak positive, meaning they look like they're kind of going up, but maybe they're bunched out a little bit more. Then we have what's called a negative correlation. So a negative correlation is just the opposite. It's a correlation in the negative direction. So I'll show you an example of that. So we would have our scatter plot points all kind of, if they're really bunched together and it looks like they form a really nice fit on a negative slope line, that would be a strong negative correlation because the points are going downward, so it has that negative slope, and they're very close together. If they're not clumped as close together, but it still looks like you have that negative correlation, you could say that it's a weak negative correlation. Again, the weak ones, they're not bunched together as much, so they're a little more spread out, but it still looks like it's going in the negative direction, meaning a negative slope. And then your other option is that you really have no correlation at all. These are the most fun to draw. Basically, you have no direction, very weak. So if you had to draw an example of relatively no correlation or no correlation, it basically looks like you took a bunch of points, like you took a bunch of glitter and just threw it on your page. So when you look at this, you look and say, I don't see a connection at all. And what that often means is that the data doesn't relate at all. There you maybe pick two different types of data that don't have a connection. They don't have a positive connection or a negative connection. They just truly look like somebody threw a bunch of points. So you will be asked to do a couple delta math where you're asked to decide what type of correlation. Is it strong positive, weak positive? Is it strong negative, weak negative? Or do you just not see any correlation at all? Now getting to actually doing your line of best fit. So in Algebra 1, and I'm not going to do too much with this question because we're not going to do a lot by hand in this lesson, which is nice. But in Algebra 1, if you were given a scatter plot and asked to come up with a line of best fit, what your Algebra 1 teacher probably said is try to draw a line that goes through at least two of the points. They may have said something like, let's make sure we have the same number of points above the line as we do below the line. It's not a real exact science because it kind of depends on the teacher of how detailed you want to get. So for example, with this one, I think we can all agree that it's definitely a negative correlation. Looks like a pretty strong negative correlation because they're all really bunched close together. If I wanted to figure out the equation of the line, I would have to figure out, well, what's the slope and what's the y-intercept? And it took some time, and my answer might be different than the person next to me because we might have picked different points and we might have drawn a slightly different line. Like in mine, it looks like mine crosses the y-axis around 4, and my slope looks like kind of looks like it's down 1, right 2. It's definitely a negative slope. And the way I drew my line might be different than the way that somebody else draws their line. And again, their answer may be a little different. But we call this a line of best fit, is negative 1/2 x plus 4. Looks like it has a slope of about negative 1/2. It looks like the y-intercept is around 4. Again, not a real exact science. You do not need to write these steps down. I just want to kind of talk you through, like, what did you do in Algebra 1? Well, first you made a scatter plot. Then you came up with your line of best fit, and you tried to find a line that looked like a pretty good approximation. This is the part that's not super exact. And then you picked 2 points on that line and figured out, well, what's the slope of those points? That would help you give an equation. And then the reason we did this is we used this to make predictions. Once we could have this line, we were able to then predict what's going to happen in the future based on if this continues with the same pattern, with the same trend. I'm going to go back. So now with technology, when we do this, instead of calling it a line of best fit, we call it something called a regression line or a regression model. So when you hear regression line or regression model, basically what this is saying is, what is the line that a calculator or a piece of technology like our Chromebook, what would that line of best fit be? So that my regression model would be the same as everybody else's in the class as long as we entered the same data. This is what businesses do. If you're trying to figure out trends, if you're trying to figure out over the course of time how much of something is produced or how much of something is bought, if maybe you're in sales, you would use these regression lines or these trend lines to figure out what's going to happen as we move forward as far as how much product am I going to need to sell, or how much profit can I expect to make. So you'll see these idea of a regression model. You may also hear it referred to as a linear regression. Now, normally when I teach this entirely with the graphing calculator. However, what I realized in messing around with Delta Math is there's actually a much easier way. I can ask you to do these questions on Delta Math, utilize the calculator within Delta Math, and save you a ton of time. So rather than doing a bunch individually and having you grab your graphing calculator and really struggling with all the data, let me show you the fastest way to do these. So here's what it's going to look like on Delta Math. You're going to be given a question like this where they're going to give you a table of data. So in this particular question, it's looking at profits for a company. X is representing how many years it's been since 2007. So we're starting in 2007. And Y is representing the profit in thousands of dollars. So for example, in 2007, the profit was $60,000. And in 2008, it was $88,000. So we can look at this set of data and use it to understand the profit in the different amount of years. So what we want to do is we want to come up with a line of best fit or a regression model for this data. We want to put the data into a table and make the calculator come up with this linear model, this line of best fit. So here's how it works on your Delta Math, and I want to take you through these steps so when you do them on your own, you remember them. First thing you're going to want to do is you're going to want to copy the values for your calculator. It's a button here. As soon as you click that button, it will automatically take all of the values into your table and store them in a calculator. You're then going to open your statistics calculator, which is the button below it. And as soon as you do that, what you'll notice is you'll see a button that says paste values. So you're going to hit that button, and it's going to take all of the data that was in that table and put it in the calculator for you. This is a huge time-saving piece because before we had to manually enter them all into a graphing calculator, and now this does it for us. So then, once the data is in there, you're going to go to your main menu dropdown, and you're going to go to your calculate menu. It's the second option. And it gives you a sub-menu. You want the one that says LINREG. It stands for linear regression. And next to it, it says AX plus B. What that's saying is your answer will be in terms of writing it as a line, Y equals AX plus B, or like slope-intercept form. So you're going to click that LINREG. The diagnostic piece, you can turn it on or turn it off. If you take a stats class eventually, you'll use the diagnostic piece a ton. In our class, I won't use it as much. I am going to turn it on just to show you what it looks like, but it is not something that you have to have on to be successful. So here's what it'll give you. It will give you your line of best fit, your A value. So when you see this A value here, your A value is your slope. That's the slope of your line of best fit. Your B value is your y-intercept. Now the things down below, so this value here, this R, This is going to tell you how strong of a model it is. The closer it is to 1, the stronger the model. So you'll notice this is 0.96, almost 0.97. That tells me it's a really strong model, and it's also positive because we get a positive value for that. I am not going to ask you much with that, but I do need you to have your A and your B value. So what you're going to want to do is on a piece of paper or next to you, you're going to want to write down your A and your B value because you're going to have to enter that into your equation. So I'm going to go off to the side here and I'm going to write down my A value, my B value. If you go back to Delta Math, so just click on your Delta Math tab, you can go back to the problem. And the question wants to know, what is your regression equation? So your regression equation is, I need a keyboard here. I need to switch to get a keyboard real quick. So my regression equation is y equals, my A value was 30.6, so 30.6x, and then my B value was 58.4. We're going to plug that in. And then it wants to know the final answer. So let me go back up and show you what the question said. So the question said, we want to use this formula to figure out the profit in thousands of dollars in 2015. So 2015 is 8 years since 2007. So 8 years have gone by. So that means my X value, which is years, needs to be an 8. So this formula that I wrote down here, here's where it does help to have a calculator. You're going to grab your calculator and you're going to type in 30.6 times 8 and then plus 58.4. You get 303.2. It wanted to the nearest $1,000, so that would be 303. 303. And then we're going to submit my answer. And I want to show you just what it looks like here because it will take you through. Here's what the calculator says. Here's your A and your B value. It wanted the coefficients rounded to the nearest hundredth. Well, they were already small decimals, so I didn't even have to round. I had my regression equation. And then finally, I needed to plug in the X value that it was asking to make a prediction. It's been 8 years since 2000, from 2007 to 2015, so I'm going to put an 8 in. It'll also show you your graph. So when you're done with this, you can actually see the scatter plot. So here's the scatter plot of all the points that were given in that table. And then here's the point that we were making the prediction on. And you can see how that line goes right through there. So let me show you another one. I want to show you one that has a slightly different question. Okay, so this one is looking at X is the number of years since 1995, and Y is the cases of the crime cases in a county in New York State. And what you'll notice is as the years have gone on, the cases have gone up. So we would see there's definitely a positive relationship here. We're going to take that data and we're going to put it into a table so we can get our regression formula. It wants all of our coefficients rounded to the nearest tenth. It is nice to look at the directions before you go so you know how to round. And then we're going to use that to project how many the new cases for 2003. So I'm going to copy my data. I'm going to open my calculator and paste my data. I'm going to go to my calculation menu and choose the one that says LINREG. Again, the diagnostic can be on or not. If you want to turn it on, it shows you how good of a model it is. The numbers that you need are you need the 30 and you need the 854.6. So 30, 854.6. Also a very strong positive model. We can tell that from the R value. So we're going to go back to Delta Math and we're going to type in our equation. So Y equals, my X value was 30. So Y equals 30X, or my slope value is 30, plus 854.6. It did want it to the nearest tenth. And then it wanted to know, we want to use that equation to figure out the projected cases since 2003. So 2003 has been 8 years. So I want to put an 8 in for X. So I'm going to go to this equation. I'm going to put an 8 in for X. So on my calculator, I'm going to type in 30 times 8 plus 854.6. I get 1094.6. I think it wants the nearest whole number. Yes, so 1095 would be my projection. 1095. Submit that answer. And again, when you're done with these, or if you give up on one and want to see it, it'll tell you what you should get from your calculator. It will tell you your A and your B values to put it into your model, and then it will tell you what to plug in to get your final answer, and it will even give a picture that represents the scatter plot. I'm going to show one more that has a little different at the end. Let me see if I can find one. Okay, I'm going to do this one to finish. So this is more crime cases. I don't know why we have so much crime going on in New York here. So this is from 1996 in the crime cases. So it's going to start the same way. We're going to put all this data into our calculator. We do want everything rounded to the nearest hundredth. So let's copy the values, open our calculator, paste the values. We're going to go to our calculation menu and we want the linear regression. I'll turn my diagnostic on again. This one has a negative relationship. You'll notice that your R value here is negative. So we actually have a negative slope. So I'm going to come off to the side. I'm going to write down my A is negative 17 and my B is 980.6. So I'm going to go back to Delta Math and type in Y equals negative 17x plus 980.6. It does want the nearest hundredth. Now, here's where this one's a little bit different. It wants to know the calendar year when it would reach 775. So to do this one, what you're going to have to do, because now you're actually solving for x, you need to set this equation that you got down here equal to 775. So you're going to have, I'm going to write on the screen a little bit, you want to know when 775 would equal 17x plus, or negative 17x. I missed a negative. I got to put that in. Plus 980.6. So I'm going to subtract 980.6. So I'm going to subtract 980.6. Grab my calculator to do that math. So 775 minus 980.6 is negative 205.6. And that equals negative 17x. So I'm going to divide both sides by negative 17. So divide by negative 17. I get 12.09. I think it wanted the year. So it's been about 12 years. So if I go up here, the calendar year. So we started in 1996. 12 years after 1996 would be 2008. So first let me make changes to a negative because I forgot the negative. And the calendar year 12 years later would be 2008. And there you go. So you can see again the calculator values, how you round it. In this case, you really didn't need to round your regression equation. And then again, if you're given a y value and you're solved for x, you're going to put the 775 where y is, and then you're going to solve that linear equation for x. It did want the nearest calendar year, which would be 12 years later. And here's my picture. You can see this negative relationship. So that is section 2.5, linear regression, scatter plots, and coming up with these equations and models.